may know him from his own YouTube channel, Going South. Although he seems to be going north every time I talk to the man, that his YouTube channel Going South.
Yes.
You know, we had Jeremy
Yeah,
Corbyn,
everything's going south. Yeah,
everything
sure.
is
It's all
going
going
south.
south, right?
Yeah,
Right. It's going south, but that it's not all or nothing. It doesn't mean that it goes south until everything completely vanishes.
Yeah, but do you think
Right? Which many people can easily say that you know it's all going south. There's absolutely nothing we can do.
When I saw skies were red, I was born and I was dead. When I saw mushroom head, I was born and I was dead. When I saw mushroom head, I was born and I was dead. I gotta keep my distance. I gotta keep my distance. I gotta keep my
All right, so here we are on the beach in Greenland, and this is a tree, a log that's gone all the way from Siberia, from the forests, down here to Greenland, and it's either taken the east coast of Greenland to get here, or the narrow strait down the west coast to get down to the capital Nuuk. In any case, it's a very nice bench and a place to go down to watch the ocean. And you got blue ocean here, so what's all this talk about the famous Blue Ocean event? Well, it's not just sort of something blue, which is also ocean. It's a specific meaning of the blue ocean and the blue ocean event, and we'll look at that tonight. So here is the Arctic Ocean, and a part of that is called the Central Arctic Basin, because you have different named oceans around the edges here. Here is the Kara Sea, here is the Barents Sea, and this is the Greenland Sea down here. So the Central Arctic Basin is about like hereabouts, and it's of course defined in the map vectors. So it's possible to apply those vectors on the on these charts from University of Hamburg, so that you get you can get a script to count how much ice is in every sea, right? And a guy called Vipnius, his artist name is Vipnius, he does that every day. He sets his computer to calculate how much ice and freezes or melts or moves in and out of each of the seas, which is a fantastic job. And of course, when he does that and publishes the numbers, we can see how soon or how fast we are losing ice in this most frigid, this coldest region of the Arctic. So this is a slide that shows the day so far with the least ice, the least sea ice extent, and that was back in 2012, September. And when I calculate the chances of having a blue ocean event in the Arctic, I have chosen to look at just the Central Arctic Basin, which is defined on maps, as I mentioned. And the reason I do that is because on this very day, in September 2012, the ice that you see here, 99.7% of that ice is within the borders of the CAB, the Central Arctic Basin. So, because on the day of the lowest ice so far, almost 100%, 99.7%, was in this very area, that makes it very useful in terms of finding how fast this area is losing ice. We can sort of just disregard all these peripheral seas, even the Beaufort and the Chukchi, because they will melt out anyway, at least in a year where you lose everything, or you lose everything apart from 1 million square kilometers, which is the IPCC scientific definition of virtually ice-free. So to have a blue ocean event, you have to get below the 1 million line. And an easy way to see if we are approaching that is that the Greenland land area is about 2 million, slightly more than 2 million square kilometers. So when you got an amount of ice about half the size of Greenland, then you are at about 1 million square kilometers, and that is the limit for virtually ice-free Arctic. And the reason it's not zero, the reason it's 1 million and not zero, is because you will always have some kind of, fjords and faraway, shadowy places where you will have some ice lurking, and also you will also have calved icebergs from the glaciers floating around in the water, and so it's not realistic to expect absolute zero ice. So, but with less than 1 million, it's practically ice-free, because that means all the ice will sort of just be floating around, and most of the North Pole area and stuff will be blue ocean, or blue sea. So we are focusing on this part of the ice here, not this, and not this down here, and not this little patch here. So 99.7% of what you can see here is within those cab borders. Right. So this is a chart that has already calculated how much you would have to lose or melt every day in order to get to that blue ocean event. How much ice do we have right now in the cab, and how much would have to melt every day for the last 100 days of the melt season to get down to below 1 million within the cab. And you can see that this red dotted line, it goes up and down a bit, and that's based on how much ice loss we have every day, or even how much gain we have, because then it will be, if you don't melt anything but you gain some ice, either by freezing or by transport from the other seas, then it will be harder to get down to ice-free. So then you can see that goes up. And the blue line is how much we actually lose per day. So it's like, it's a sort of very start of the melting season in the coldest region of the Arctic. So sometimes you lose a little, and then you gain a little, and so it goes sort of up and down. And on this chart, it's only one day where you actually melt more than what you would have to melt every day. And that's why we had only a 3% chance for this to go to a blue ocean event. But we will see on the following days here. Yeah, there you have at least melt. It's not below zero, so there is some melt. And some melt on July 4th. July 5th, you almost get up to the requirement, but not quite. Close but no cigar. And then July 6th, we had a melt of about 82,000 cubic square kilometers. So that was better than the melt requirement. And for the last day, July 7th, we're also above the requirement, and that means you can see that the red line is falling. That means it will be slightly easier. If we can keep up the same melt, it will be slightly easier per day for the rest of the 100 days, right? So what does this mean for the chance? For the chances of a blue ocean event? Of course, it's better chances because you have more days above the requirement. So now we are up to 10% chance of a blue ocean event. At least, by the way, I've chosen to calculate it on this setup. And you can see there are 4 other years, 2016, 19, 17, and 19. And of course, they won't succeed in having a blue ocean event because it never happened before. It never happened in like 2 or 3 million years. So if it happens this year, it will be the first time it happens. But I've included the other years so that you can have some sense of there we're at. You can compare it to the other years, where you can see that last year, 2019, it indicated 20% chance by July 7th, and it's really like a 10%. So it's absolutely not a certainty that we will get there this year either. But we're not it's not the worst year anyway. It's better than 2018, 2017. Right. So we left off last week with a 10% chance of a blue ocean event, but that was assuming that July 7th was above the dotted line for required daily loss. But after that, July 7th was recalculated at the data source at Vitnews website, and it came out to be just below the required line, and that means we were not at 10%, but rather at 7%. So that happens sometimes, and I don't see any reasons to doubt Vitnews work, so I go with that. Okay, so on July 8th, the first day in this weekly update, we were below the line, continued to be below the line, and July 9th, we had actually a gain of ice in the Central Arctic Basin, or CAB. So we gained ice, not necessarily because it froze, but maybe because of transport of ice from the other seas into the Central Arctic. So, and another day, July 10th, of gain in the CAB. You can see these gains make it harder for the requirement will be harder for the rest of the 100 days until the end of the melt season, because if you don't melt it now, you have to melt more later, basically. So, July 11th, we go straight from a gain and to a melt higher than the requirement. So now we're up to 10% again. And we get another day above the requirement on July 12th. And where do you think it's 3 days in a row above the dotted line? So that means we have 17% chance of a blue ocean event in 2020. And you can compare that only to 2019, which had 20%. So it's beginning to look like the best or worst year so far for getting close to the virtually ice-free state in the Arctic. And yeah, we can look back at this one. So over the weeks this summer, we're going to complete the final 100 days of Arctic melt, and it's kind of like an existential thriller or drama in real time, because these 100 days, they determine so much. They determine so much about the near-term climate future, because as I alluded to in the cover graphic of this video, you get a darker Arctic when it melts. You shift the albedo, and the darker it gets because of the melted snow and ice, the more heat from sunlight it attracts, and then But you know, under the surface, you have another major climate bomb called methane, which is logged in permafrost that was flooded some 10,000 years ago. So, of course, permafrost on land is thawing very rapidly. But imagine if you have a warming Arctic Ocean that is, liquid. It gets in all over the place into the permafrost from the liquid state under the surface, and that is, of course, also melting like a house on fire. And it's been compared to 10,000 champagne bottles, and when they start to pop, you get this very, very potent climate gas called methane into the atmosphere at once, and it only starts popping because we are warming the planet, and it won't get any less warm or less rapidly warming when those champagne bottles start popping. And of course, champagne bottles is just a figure of speech. It doesn't mean that we are going to celebrate it, or maybe some people are going to celebrate it, but it's just an attempt of explaining the things. Okay, so my buddy Seymour Rocks is going to finish off this episode with his little video about the methane emissions that are already higher than the peak of 2019 at the start of this year's melting season in the high Arctic. Okay, bye.
This is Seymour Rocks reporting from Down Under. I just want to do this report because Margot did a video yesterday, and she came up with some very, very important information that I want to share with you, but I want to share some other things as well. So I'm just going to move on with some general things that I've taken, and from Twitter and so forth, and then move on to the other stuff. So I'm just going to share the share. So this is okay. Let's just get this. Okay, so this is the forecasting. This is from Denmark or Norway, and this shows the weather forecast for the North Pole. That was Tuesday, the 14th of July. It got up to 2 degrees Celsius. I've noticed that there was some kind of breaking up of ice in the central Arctic region, and that seems to have closed up again. But I'll show you exactly what I see is happening. So let's just go on. So this is the Arctic sea ice extent for the latest data, and 2012 was the year to beat, and it looks as though we're beating it. We sort of went kind of Steven with 2012 for a little while, and now we're moving back out again. And this is from Eric Holthaus on Twitter, saying 2020 is now likely to end as the warmest year in recorded human history. We are in a climate emergency. Some of us have been saying that for years. And then I picked this up. This is a picture from the fires in Siberia from today. It was clear sky, the northernmost currently active Arctic fire, seen at 71.3 degrees north, south of the East Siberian Sea. And that's taken from Copernicus. And this shows the Siberian Arctic, and Zach Labes is an absolutely brutal year for the Siberian Arctic. That's the sea ice on the left. That's the temperatures on the right. And this is from Climate Reanalyzer. This shows the maximum temperatures in the Arctic, and it's been like this kind of for weeks and weeks. So it shows it as confirmed by for the forecast of being above 0, and there are some absolutely amazing temperatures elsewhere in the world, Africa, United States, Europe, you name it, but I won't be going into that. Okay, and this shows the temperature of the sea around the Arctic, Central Arctic Basin, and it shows that's the ice. So that's the warm water that's eroding the ice from underneath while we have these peculiar weather conditions. And it seems to me that the jet stream is just kind of very, very weak, and weather conditions are just staying sort of plonked wherever they are. I mean, if you look at China, they've been having floods for weeks and weeks and weeks, and it doesn't seem to be going away. Okay, and these are the sea surface temperature anomalies. So you can just see huge anomalies in the Russian Arctic, and then there's this huge blob off the coast of the west coast of the United States. Meantime, we're having a different winter down under New Zealand with much cooler temperatures, and we even had a kind of a frost today, and I realized that is because whatever the meteorologists might say, it's because the hot blob and the Tasman Sea and the seas around New Zealand have gone at the moment. So we're just having reasonably equitable conditions, although it's warmer than what it has been in kind of on average in the years gone by. Okay, so I just want to look at concentration. This clearly shows just how much ice has disappeared, but the situation I think is even worse than that when we start looking at the sea ice thickness. So, and that's from another source. It practically confirms the other ones. And then there's this was interesting. I haven't got a color chart, unfortunately, for this, but it just shows how the ice is disappearing, just from different sources. And I'm not even going to name them because this was sent to me, and I don't know exactly where it's from. I think it's from a European source. And finally, we get to sea ice thickness. So that is, that was actually in. Why am I showing this? This was in June. So that's how. Now just have a look at, see how this is something that frightened me. This really gives a representation. This is the sea ice. This up the top, that's about 0.5 meter thick. The blue is about 1 meter thick, and then this area is 1.5 to 2 meters thick. So this shows that from an Arctic that used to have ice that was 20 feet thick, it's gone down to this, and this is in 3 weeks going into a forecast period, and you can just see how the ice is just disappearing before our eyes. And not only are we reduced to this small area here of thicker ice, but you can see this area of red, and then you can see how gaps appear here as the ice recedes from the coastline. So I would interpret that as to say, well, it don't look too good. Is the methane emissions at surface level from Sunday the 12th going through to Thursday the 16th. So some of that is a forecast. You have to bear in mind that the light green, is already at 2020 parts per billion, and the red that's coming off Severnaia Zemlya is somewhere higher than that. And then of course we're seeing there's huge amounts of methane coming off in Siberia, and also in Scandinavia as well. I think it's quite significant. Margot has been doing an excellent job over a year or so, maybe longer, at monitoring and recording the average methane readings at 500 parts millibars. So last week she measured an average of 1,882.75, and since then it's gone up 4.5 parts per billion to 186.7 parts per billion. But that's not the entire story. So here it is in a graphical form. This is the months from March 2019, and it reached a high in last year in October, because we're moving into the period now where the methane levels start to go up because of the warmth of the Arctic. And what's happening now is it's starting to go up again. But the whole point is that it's at a completely different level. So last year she measured the highest level of methane for the whole year was 1,885.75 parts per billion. So now at 1,886 parts per billion, we've already exceeded that level, and that was the highest. So just to give a sense, here we are at the highest last year, and the levels are just starting to go up again. So we're at the beginning of that process, and we've already exceeded the levels of methane that are being released. Now that's at 500 millibars, not at surface level. So I'm going to go on and just have a look at what CAMS is showing for methane at the surface level. Is from Margot.
I wanted to show, this is NASA Worldview, I'm going back 10 days. This is sea ice concentration, and the reds, it goes down backwards in the rainbow for how much it's melting. But you can see where it was melting back then. Let me take out these clouds. We'll go to the blue marble layer, turn that on. So let's go through this and you'll see what's happened since July the 2nd. And we can see the melting, high melt that day. That was on July the 4th. Here's the 5th, the 6th, 7th, 8th, 9th, 10th, 11th, and today. So we got another high melt day. Look, it's going up. That's what I said it was going to do. It's going to be melting from the coastline out here, which is what it's doing now. There's a hole forming here, just north of Canada. That's in the Beaufort Sea. Here's the North Pole. So let's turn the clouds back on. And we'll turn this concentration off.
Shows just where the cloud is. The green area shows that that the sky is clear, and the temperatures are about yeah, well, anyway, yeah, so we'll get rid of that. So that shows us that. Okay, so this is a general view of the Arctic. It's the North Pole here. So you can see just how much ice has melted. All of this is cloud here. This is completely melted. So let's just go in a wee way. So you can just sort of see around the edge of Siberia. This is eastern Siberia. That's Alaska here. It's all melted. This is all under cloud here. All around here. That's cloud. It's a little bit hard to tell. So let's just go in and have a look here. So I'm always interested in what's happening to the so this is what the ice looks like. So it's evidently that doesn't indicate very thick ice to me. I don't know whether those are melt pools, but the sign of some sort of fracturing here. So let's just go in, and then if we go all around in the Beaufort Sea, of course last year all of this Beaufort Sea was had melted by now, but you can see right around where you can see the ice breaking up, and especially here, this is where the thickest ice has been, and until I think last year the ice was pushed right up against the landmass, but now that's starting to sort of break away here. All of this is completely ice-free. Norway Zemlya is completely ice-free. There's a lot of cloud there. and the edge of the ice seems to be at around 80 degrees north. So next I want to have a look at the sea ice thickness, because this just scared the pants off me, I must admit, when I saw this. Okay,